This RAM. You can get it with 1, 2, or 4 gigabytes of RAM. A significant improvement is that the Ethernet port provides true gigabit speeds via a dedicated channel to the CPU. In all the Raspberry Pis, the Ethernet port was connected to the USB controller, which resulted to a very much reduced performance. The board itself is slightly larger and has a different geometry compared to the older Raspberry Pis, so your old cases will not fit. The new Raspberry Pi also has a USB Type-C power connector and 2 micro HDMI connectors instead of one full-size connector. These HDMI connectors can support one 4K monitor each. The Ethernet and USB ports are also switched around, and 2 of the USB ports are now USB 3.0 compatible. The CPU and its architecture is brand new. It contains 4 64-bit processing cores and a powerful graphical processing unit. The new architecture also supports larger amounts of RAM, and the Raspberry Pi 4 comes with up to 4 GB of it. And all this means that the Raspberry Pi 4 is much faster than the older models. Here's some of the benchmarks published by Gareth Halfacre, and these benchmarks are revealing. You can see my source at the bottom right corner of this slide. The Raspberry Pi 4 dominates in all comparisons. It's not just faster, it really demolishes old records. The system on a chip CPU is a Broadcom BCM2711B0 quad-core A72 and 64-bit processor, which is running at 1.5 GHz. It's about the same speed as the processor of the Raspberry Pi 3, but its architecture brings in a much faster performance. It's an ARM v8 architecture. The graphics processing unit is a GPU from Broadcom again. It's a Video Core 6 at 500 MHz. If you look at communications, we can have a look at the USB performance, and we see that it's much faster than before. What this means is that if you use a fast SD card, your boot times and disk operations in general will be much faster than with the Raspberry Pi 3 and before that. Now let's have a look at the components that you find on the Raspberry Pi 4 board. At the top of the board, you'll find the standard 40-pin connector, which is backward compatible with the one that you find in older models. At the top left corner is the wireless controller, which provides Wi-Fi 802.11 AC, BLE, and Bluetooth 5.0. Towards the middle is the Broadcom BCM2711B0 system on a chip. Next to it is the RAM module. You can get your Raspberry Pi with 1 GB, 2 GB, or 4 GB of LPDDR4 3200 SD RAM. The one pictured here is the 4 GB model. On the top side, you'll find the Gigabit Ethernet transceiver chip, and below that, the USB 3.0 controller chip. Having a look at the details on the left side of the board, you'll find the 2-lane MIPI DSi DisplayPort, where you can connect a touchscreen just like in the previous models. Then at the bottom of the board, you'll find the 2-lane MIPI SCSI camera port and the 4-pole stereo audio and composite video port. A new connector that did not exist in previous models is right next to the Ethernet port. It provides power over Ethernet with the use of a separate PoE power over Ethernet hat. Now at the bottom of the board, you'll find a row of connectors, which include the USB-C power connector on the left. You should use a power supply that is approved by the Raspberry Pi Foundation that can provide 3 amps of minimum current at 5 volts or 5.1 volts. Now, because of the way that the Raspberry Pi Foundation has designed this USB-C connector, many USB-C power supplies that you'll find in the market are not compatible with the Raspberry Pi 4. So be careful here to do your research before you attach an existing power supply to this port. In my case, I just wanted to take no risks and purchased one from the Raspberry Pi Foundation to match the Raspberry Pi 4. Now towards the middle of the bottom row, you'll find 2 micro HDMI ports, which allow you to connect them to a 4K display with up to 60 Hz of refresh rate. Now, a few things about cooling. The Raspberry Pi 4 can get very hot thanks to its very powerful CPU and other components. While it can automatically throttle its clock to prevent damage from overheating, it's a good idea to attach a generous heatsink. There are many to choose from, including active systems with fans or passive ones with just a heatsink. In my case, I chose a massive top and bottom heatsink that also acts as a case. This heatsink escapes heat from the CPU, RAM, and USB controller chips via special adhesives into the environment. Because of the size of the heatsink, I had to use a header riser to maintain access to the GPIO pins. And in these photos, you can see the assembly process that I followed. The bluish pad material is a special adhesive that improves the rate heat conductivity between the surface of the integrated circuits and the heatsink. These pads are very sensitive and fragile, so be very careful when you install them. You need tweezers. With a header riser, I can now access the GPIO pins easily. Before we move on to the next lecture, I want to point out that for the purposes of this project, the Raspberry Pi 4 is in a way an overkill. You can easily implement the project on an older and slower Raspberry Pi. However, older models, we can see those down here, like the Raspberry Pi 3, Raspberry Pi 2, and even the original Raspberry Pi with just modifications to its connectors are also available. Plus, we've got the Raspberry Pi Zero, like the minimal Raspberry Pis. So I wanted to update this lecture with some information about Raspberry Pi 4, and I've also left the original version of this video intact because it's talking about earlier and cheaper Raspberry Pi models. So I have a dedicated lecture on the specifications of the Raspberry Pi 4 earlier in this section, but what I wanted to say in this lecture specifically about which board should you get is that it doesn't really matter. What we'll be using the Raspberry Pi for in this course is not resource intensive. It doesn't require extraordinary amounts of computational power or RAM or graphics processing capabilities. It's a web application which basically requires Python, Nginx, and other below the hood software capabilities, as well as some basic hardware capabilities which are available on all of these boards. As I was saying in the Raspberry Pi 4 lecture earlier, the one about specifications, what I really like about the Raspberry Pi 4 is its speed when we are compiling packages such as the Python 3 interpreter, and then when we are compiling the C packages from the source. Things like that happen really quickly on the Raspberry Pi 4, and they did happen quite quickly as well on the Raspberry Pi 3 when compared to earlier models. But once you are done with the processing intensive tasks and you're left with operating the web server that is the core of the application, the differences are not that visible. So the Raspberry Pi 4 will execute the web application faster, of course, than the Raspberry Pi 3, and actually you can feel the speed, but it doesn't really make that much of a difference. So to answer the question, which Raspberry Pi should you get, I would go for the Raspberry Pi that is the fastest that your budget allows. So the one that I have done my latest testing is a Raspberry Pi 4 Model B with 4 gigabytes of RAM, which retails here in Australia for about 100 Australian dollars. So that's the most expensive Raspberry Pi. However, I have done the exact same testing successfully with no problems whatsoever with my Raspberry Pi 2 Model B, which is still operating after many years of running this application, and this is less than half of the price of the Raspberry Pi 4. Remember that with the Raspberry Pi 4 as well, you also need to invest in a heat sink, which is another $20, and you probably want to get a faster SD card as well to take advantage of the faster disk performance of the Raspberry Pi 4. So that brings up the costs where you don't have those problems with the Raspberry Pi 2 Model B. You can also use the Raspberry Pi Zero wireless. You need to attach the header, and then you get the lowest cost Raspberry Pi that is compatible with the content of this course. So with that all said, I'm going to now take it back in time when I did the original version of this video and talk about the other Raspberry Pi model family members. At the time I'm recording this video in February 2018, the most popular Raspberry Pi is this one here. It's the Raspberry Pi 3 Model B. This Raspberry Pi is the fastest Raspberry Pi available, and it has integrated Wi-Fi and Bluetooth capability. Before this Raspberry Pi, there was the Raspberry Pi 2 and the Raspberry Pi 1 Model B. I've got one of those right here. Actually, this is a fairly old Raspberry Pi. It's the first Model B that came out. And I remember that the Model B is the Raspberry Pi with the 40-pin connector. When the very first Raspberry Pi came out, it had a much shorter connector. There was the Raspberry Pi Model A, and then Model B extended the connector to have 40 pins on it. So as you can see, the form factor is identical. Both have got the same number of ports, Ethernet and USB. They both have HDMI and USB and the audio jack coming out, and they both have the connectors for the camera and the display. These two are for the display, which also provides you the ability to connect a touch screen display too. If you flip them over on the other side, you'll see that while the original Raspberry Pi B Plus has got a USB connector here and here, they both do, the original one doesn't have the additional memory. So this is a memory chip right here. It provides the Raspberry Pi 3 Model B with 1 GB of RAM, whereas the original Raspberry Pi Model B only had half a gigabyte. So that makes actually a big difference in terms of performance and the ability for the Raspberry Pi to work with newer operating systems that require more memory. Apart from the Model Bs then, we also have, about a year ago, Raspberry Pi Foundation released into the market this tiny Raspberry Pi. This is the Raspberry Pi Zero, and the one that I'm working and I'm using here in particular is the Raspberry Pi Zero with Wi-Fi and Bluetooth integrated. So you can see that everything is miniaturized. You've got a mini display port, mini HDMI, you've got mini USB ports as well, and the same spring-loaded SD card connector as well. And you can also connect a camera. So this connector here allows you to plug in the same camera ribbon cable that you can use with your Model B Raspberry Pis. So this is a great option if you want to build a gadget around the Raspberry Pi and you want to make it as small as possible. You can even purchase the same Raspberry Pi but without the headers attached, so that makes it even thinner, and you can solder your Raspberry Pi directly onto the printed circuit board of the gadget that you are building. So if I was buying my first Raspberry Pi today, I would definitely go for the Raspberry Pi 3 because of its speed. Basically, it's got everything that you need out of a Raspberry Pi. There's probably a lot of Raspberry Pis out there as well, like the original Raspberry Pi 1 Model B+, which is good. I would recommend that you don't buy the very first Raspberry Pi with the short GPIO header, because you will be missing the availability of the extra GPIO pins and of course the speed. In terms of which Raspberry Pi should you get in order to complete this course, I'd say it doesn't really matter. Just get any Raspberry Pi that you can get your hands on, including the original Raspberry Pi Model A, which is actually what I'm using for my own Raspberry Pi full stack application, and it's been running non-stop for the last 3 years, because we'll be disks. It's got the ability to connect to networks with the Raspberry Pi 3. You can also connect to Wi-Fi, so you can connect to the internet wirelessly. It's got all the features that you expect to have on a computer, and it's also got respectable specifications. So the Raspberry Pi 3, for example, has got a processor that runs at a 1 gigahertz rate and a full gigabyte in memory running the Linux operating system. So let's put that here. So you've got Linux. On the other hand, you've got the Arduino, which is not a computer as most of us understand it. It's a microcontroller. Think of a microcontroller as a tiny computer without any of the things that we expect in a desktop or a laptop computer. So the Arduino, for example, has got very little RAM, just 16 or 32 kilobytes of RAM, depending on the version. It doesn't have the ability to connect to a network like the internet, for example, without additional components. It doesn't have that much memory in which you can store your programs. The Arduino Uno only has 32 kilobytes of flash memory for such purposes, where the Raspberry Pi can accept gigabytes and gigabytes of SD cards that provide memory for that purpose, for the disk. Apart from that, as we expect from a microcomputer, is performance. When you've got a computer with a 1 gigahertz clock rate of its processor and a gigabyte of memory and lots of gigabytes of disk space, these are significant resources that we can use to do very interesting things. You can run an operating system like Linux, as I said, but you can also use it to play games or to write large applications and even run web servers, and none of that is possible with the Arduino, which is limited to what its microcontroller can do. So right from the bat, you've got two devices that are totally different, and that's because when they were designed, a microcontroller was optimized, or was built to be optimized for doing something small and doing it constantly and repeatedly. So for example, if you want a gadget that measures the temperature and the humidity in a room, and then depending on those single two values to turn on a fan or an air conditioner, then something like the Arduino or a microcontroller in general will be the best technology on which you can build such a gadget. If you want, however, something that can do this plus a few more things, such as control perhaps a security system like try to recognize a person's face from a video stream and then send out an alert or turn on an alarm and log that event in an online database. And we're talking about many more tasks that need to be individually programmed and supported and provisioned for, then the Arduino would be totally inadequate for something like that, and you'll be looking at the Raspberry Pi. So the Raspberry Pi is great for general computer stuff, whereas the Arduino is great for things that are small in complexity, small in programming size, and repeat constantly. A great thing about the Arduino is because of all its input and output pins and its ability to connect them to actuators and sensors, so things such as relays and switches and motors, then the Arduino is really a good choice, really optimized for sensing and controlling the world around it, as long as this level of sensing and controlling doesn't become too complicated. The Raspberry Pi, on the other hand, can do a lot of what the Arduino can, plus a lot more that the Arduino definitely cannot do. So the Raspberry Pi is capable of performing a huge range of tasks. Now, just like the Arduino, the Raspberry Pi does have a bunch of general purpose input-output pins that you can connect to actuators and sensors, just like the Arduino. So there's definitely a good case to be put forward that says that the Raspberry Pi can actually do everything that the Arduino can, therefore you don't really need the Arduino. But there is a flip side to that. The great thing about the Arduino, and that's why I love it personally, is that it's simple. The fact that there is no operating system to worry about means that you don't have to gain skills. It can take a long time. It's a steep learning effort to learn how to use an operating system in order to just be able to turn an LED on and off, or an external appliance on and off via a very simple relay wiring. So for beginners, I always say that the best way to get started with electronics and with control applications is through the Arduino, and get an understanding and capability and skill in using the bare minimal infrastructure that a microcontroller provides before moving on to something more complicated. And as a matter of fact, if you think about it, when a new person comes into the world of electronics and control, their objectives tend to be fairly simple. Just blinking an LED very often is a great achievement, and it is really an achievement when this is something that you've done for the first time. And then spinning a motor, it's the same thing. It's a very simple thing that you can do really quickly with the Arduino, but with the Raspberry Pi, you can't. There's a steep learning curve that you've got to go and conquer first. So simplicity is definitely where the Arduino wins big time. The Raspberry Pi as a computer is complicated. You might as well learn how to use Linux on your computer inside a virtual machine before you move on to the Arduino. So in other words, the Arduino is best for beginners. Now, in terms of programming languages, the Arduino is programmed in C, C++, and the Arduino team has built its Arduino, or so-called Arduino language, based on C and C++, which is another great advantage of the Arduino. C, C++ on its own is a fairly complicated language. It does have a steep learning curve on its own, but thanks to the simplification that the Arduino layer on top of C, C++ provides, it is easy or fairly simple and quick to be able to be productive with the Arduino, writing C, C++, even though beginners don't really know about this, fairly quickly. On the other hand, the Raspberry Pi, being a full microcomputer, has a wide range of languages that you can use to program it. Any language pretty much that you can use in Linux is also available for the Raspberry Pi. By default, it comes with support for C and C++, and Python. You can also install other languages like Ruby, PHP, and many other things. Pretty much everything is available. So take your choice, and if you're proficient in any language, chances are that you'll be able to use it with the Raspberry Pi. Most of the Raspberry Pi documentation, especially for educational purposes, is written in Python, which is a high-level language. It's got a very short learning curve, so even if you've never done Python in the past, you'll be able to pick it fairly quickly, at least when you compare it to other languages like C and C++. Hardware-wise, the Raspberry Pi is more complicated also because of the amount of built-in capability that comes on board. So Raspberry Pis come with video out, usually as HDMI, except for the first Raspberry Pi that had composite video output. You can connect a camera to it and do things like face recognition or object recognition with a bit of artificial intelligence. It's got a built-in Ethernet port, especially for the B+ boards, and the miniaturized version of the Raspberry Pi, which is the Zero, doesn't have a built-in Ethernet port, but there is one version with Wi-Fi and Bluetooth, including the Raspberry Pi 3, which has integrated Wi-Fi and Bluetooth. Apart from that, there's multiple USB ports, so you can connect your keyboards, mice, external video cameras, and anything else pretty much that has a compatible driver for the Raspberry Pi running Linux. And through its GPIOs, you have access to communications protocols such as I2C, SPI, and UART serial. On the other hand, the Arduino looks like it's lacking in almost every respect. It does have USB, at least the Arduino Uno, it does have USB, but it's not a USB host. It's a USB port that allows you to connect your Arduino to your computer, to power it, and also to provide serial communication channels, so you can use the USB port to send and receive text from the Arduino. And through the Arduino's GPIO pins, you also have access to I2C, SPI, and the UART channel as well. Finally, we've got the power consumption. And as a computer with a lot more resources and hardware to power, the Raspberry Pi requires a lot more current power to consume compared to the Arduino. So you need a 1 amp power supply, for example, at least, to power your Raspberry Pi, and more than that if you have things such as touch screens connected to it and cameras. The Arduino, on the other hand, very low power consumption needs, so you can power it at 20 milliamps, for example, versus 700 milliamps for the Raspberry Pi. And of course, that depends on what else you have connected to your Arduino. But another nice thing about the Arduino and the microcontroller technology is you can programmatically control the power consumption of the Arduino and reduce it and increase it on schedule as needed. So you can put your Arduino to sleep, for example, for a few hours, days, then get it to wake up a while later, perform a task, then go back to sleep again. Got the USB ports, it's got the Ethernet port, audio jack, HDMI, USB. This is the display connector, so you can connect a 7-inch touchscreen display, and there's also a connector here for a camera. None of those, of course, is available on the Arduino. In terms of processing, that is done on this Broadcom chip. It's a 1 GHz processor on the Raspberry Pi 3, and it's got a gigabyte of memory as well. As far as the Arduino is concerned, here is the Atmega 328P with very limited capabilities compared to the Broadcom chip. Much of the power of both the Arduino and the Raspberry Pi come from the GPIOs, their connectors, and what you can put on the GPIOs. So for example, for the Arduino, you can attach shields like this one, and immediately your Arduino is able to do so much more with this screen and with the buttons on this particular shield. But similar shields are also available for the Raspberry Pi. So here's something equivalent, for example. So this is a hat, as it's called, which contains a 2x16 characters LED screen. It's got an infrared sensor, so you can point a infrared remote control to it and control it remotely. It's got a little potentiometer with a button here and a bunch of buttons as well on the bottom of the hat, and you can attach it on the Raspberry Pi's GPIOs like that. So that looks quite familiar, doesn't it? Both totally different devices, but similar kinds of attachments on the GPIOs. I've got another example to show you on this Raspberry Pi 3, which is quite interesting, and it's this screen. It's, I believe, a 4-inch or approximately 4-inch screen, or sorry, 3.5-inch, and it's also capable of sensing touch, so you can use it in conjunction with this stylus and then interact with your Raspberry Pi directly with the screen. No keyboard required. So connect that over there like that on the GPIOs, and then off you go. You've got a computer with a touch interface, a mini computer with a touch interface. Really nice, quite easy to set up as well. So those are some of the differences between the Raspberry Pi and the Arduino really quickly as far as the hardware is concerned. But another thing that I want to point out is that, of course, both Arduino and Raspberry Pi can be used alongside a breadboard where you can try out small circuits. The only difference is that the Arduino has got female headers while the Raspberry Pi has got male headers, and that means that you need to be a little bit more careful when you're ordering your jumper wires. So if you want to use a breadboard with your Arduino, you need to use male to male jumper wires so that you can simply plug them into the header and then into the Raspberry Pi. On the other hand, if you want to work with a breadboard and your Raspberry Pi, you need to use jumper wires where one end is male and the other end is female. So that way you can plug the female end on the Raspberry Pi and the male end on the breadboard. Now, one last thing before we finish with this lecture is the fact that the Raspberry Pi, being more complicated, is a lot more sensitive in terms of static electricity damage and other damage caused by, for example, short circuit and things like that on the circuits that you're working on. I've never been able to I've never actually damaged my Arduino, always taking some basic precautions like working on an anti-static or static-free mat and making sure that I'm not charged up by touching a metal casing of my power supply, things like that, just basic precautions. But following the exact same precautions with my Raspberry Pi actually has resulted to a couple of burned